Yes, a few words to my person. First of all, as said before, it's introduced Carsten Gregorius. I'm working in the product marketing department of Mixed Contact, responsible for the relay business in our department, and I'm more or less 20 years now in the business of safety. Started my job as an expert as a judge in Hanover, and during several stations I started here my job at Phoenix before 4 years ago. For today, I call it safety is more than a product. We would like to discuss about several topics regarding CE marking of machinery as we see it gender. Nevertheless, we would also like to talk about the legal requirements which are defined in the European Machinery Directive and the related harmonized standards. We will also discuss about the procedure of risk assessment and the so-called risk reduction methods, related protection measures, and of course one topic or major topic of today will be also the part of so-called functional safety and the related products for functional safety. Okay for you, and I would like to start some explanation regarding what is in principle safety in our daily life. As you see on the figures and the illustrations, for example, an escalator application, as you know, is in shopping malls and in other buildings. There we have to take into account that the children will use this escalator stairs. So that's part of the assessment, let's say, where we have to take into account that all different people, children, as well as adults, will join this escalator. The hazards caused by this escalator are, of course, suddenly stopping of the stairs, for example, or reversal movement of the stairs, and lots of other things. And all these kinds of things has been regarded the manufacturer of the escalator, and we'll put it in a kind of risk assessment, as we will see it later. Yeah, safeguards, as you see it as you will see it on escalators and stairs, is a so-called emergency stop device. It's here on the right, this red color, yes, let's say component. And what you expect if you will pull on this safety component on this emergency device? Of course, you would expect that all kind of movement will be stopped as soon as possible. Of course, you will never accept that in case of any failure inside this component or the drive or wherever, that the movement will not be stopped. So, of course, you have a high expectation and high trust in this kind of safety components. This is, of course, the reason why we are doing this business, because the expectation of people is very high, and of course, this will also be covered by the assessment and standards as well. So discuss when we compare, for example, the data with typical machine hazards, we will see some deviations. For example, typically when we are talking about machine hazards, we have to deal with mechanical hazards, not necessarily, but or exclusively, but with mechanical hazards, such as, for example, resulting by cutting or shearing hazard by a saw, for example, as we see it in the left corner here. We have to deal with falling objects, lifting objects, where we have crushing or impacting hazards to the people, to the operators. Also to deal with moving parts, rotating parts, for example, which is, for example, caused by robot systems. Moving objects, conveyor systems, typically will be, for example, drawing in or rubbing or impacting. We have to deal sometimes with gravity. Think about lifting platforms for vehicles, for cars. And so on and so on. So these are just some examples, some ideas. What are typical machine hazards? Of course, there are much more, like electricity, like noise, like shock and vibration, and lots of other things. But of mainly machine hazards or mechanical hazards. The overall risk assessment is an essential part of the CE marking procedure, and the risk assessment procedure is described in an international standard called ISO 12100. International standard, which is adopted also in North America, of course in Europe, but also in other countries in Asia, for example. So it's a very international standard and worldwide accepted. So the general procedure is written or is shown at the slide number 5. Start with the first step, which is called determination of the limits of the machinery. What is that you have to define the so-called intended use machine. So that means for what reason or for what is the typical application of the machine you have to design. You have designed it for. The intended use might be a woodworking machine, which is designed for cutting or sawing wood, not for cutting and sawing metal sheets or plastics or something like that. So for also define the qualification of the people who are allowed to work with that machine. You have to define the physical borders of the machine, the end supply, for example, and lots of other things. So from that, you will move to the second step, which is called hazard identification, as you see it here. The hazard identification is related to the hazard list as we have seen before. You have to allocate the hazards which matter to your machine, and you have to say, okay, this mechanical hazard is related to my machine. This electrical hazard maybe is not related to machine. So in the end, you will have a file, let's say, Excel spreadsheet where hazard has been identified and yes, specified from a table, for example. To the annex of the standard, you will find such a table, which will help you during the risk assessment process. So that means my recommendation would be have a look to this annex of the standard, and then you will have a good guidance for the hazard identification. As you have identified each hazard, you have to estimate and evaluate the related risk for this hazard. And the whole complete procedure is defined as risk analysis, as you see it here. We have covered all these 4 steps. You have to come to the decision: is the machine now safe enough, or need to do some for risk reduction? If you have decided no, the machine is safe enough, you will can stop with the procedure evaluation. If you have to say no, I have to do something, I have to put some things to the design concept, then you'll be in the risk reduction or hazard reduction procedure, and that is in principle the next part of the process. Yes. You all agree that risk is never achievable. So in the final end, we have to deal with the so-called risk on acceptable residual risk. But this is in detail. That is the part of the assessment you are doing for your machine. A little bit about these 3 different steps for risk reduction method. The first step, as we will start, is the so-called inherently safe design. This means, or to give you some example, for example, one possibility to increase the risk is to minimize gaps, for example. The example is to minimize this gaps or minimizing or maximum safety distance will lead to a safe concept. Or example is to reduce forces, speeds, pressures, for example, for movable parts on the machine. So things are an internal design part. So that's the reason why it's called inherently safe design measures. So this is the step where the design part or the integrity design have a direct influence to the machine risk or not. So that's the only step to eliminate hazards or reduce the associated risk by a suitable choice of design features machine itself. So that means this is an essential part of the designing process. Cover all this risk just by inherently design measures. In many cases, we have to provide technical risk reduction measures, such as things like studying or so-called complementary protective measures. And here's what this might be. On the left-hand side, you see some examples for fixed guarding systems, for example, fences, for example, which will be mounted on the floor to avoid access or direct access to the tool area of a machine line for production line, for example. Or on the right-hand side, you see an example for some movable guards. For example, a movable guard is including part of the movable guards in combination with lock devices. In other words, so far you will open a safety door to enter a hazardous area. You will have an immediate stop of all dangerous machine movements, for example. More technical risk reduction measures, as you will see also in some other literatures. For example, we talk about light curtains, we talk about bumpers, protective mats, and lots of other things, which will be step 2. A question which will rise up very often is what is the situation for an e-stop? How would you classify this the protection device? Now, an emergency stop device is a typical for a so-called complementary protective device. So that means its priority, the machine should be as safe as is possible by just using technical risk reduction measures, as we see in it here. But an emergency stop device is an elementary part of the overall concept, but it's not direct so-called primary risk reduction measure. So it's an important device, but safety itself of a machine should be a higher priority as the just an e-stop concept. Next step is the so-called user information. Here we see some examples. This can be warning signs for pinch points, warning risk of high noise levels, wearing ear protection, but it's also technical documentation like user manuals, as we will provide this, for example, for our safety products, but also might be a part of this step 3. So things are so-called organizational measures and should be the last part in the risk reduction process, but it's also an important part of the overall process. So all 3 steps should be seen in the right order. Start with the step 1, follow step 2, and the step 3 is the last level in the risk reduction process. Okay, so far we have discussed a little bit about the ISO 12100 and all the related assessment procedures. I would like to spend some words about the CE marking in general. Of you know the visible sign of the CE on different products for daily life. So think about a machine which we'll buy for example, in the shop in your where you will find this on machine tools, on machines sometimes, or in many cases. But you will find also the CE mark on toys, for example. More every electrical equipment, and this is based on visible sign that the manufacturer declares this product is complying with one or more European directives. So it's not in a third-party approval. It's a manufacturer's declaration. He ensures that his product complies with at least one of the European directives, as we have it, for example, for the machinery directive, low voltage directive, ATEX directive, EMC directive, and much more. Talk about, or when we focus on machinery directive, we have to talk who is addressed by this directive mainly. And of course, it's manufacturers and importers of new machinery placed for the first time into the European community. But also users might be addressed. For example, for those who are finishing so-called incomplete machinery. Let's imagine that an end user is buying several subcomponents, a motor, for example. The motor will be combined with the tool and a mechanical arrangement around it. And now, in this case, the end user has become the role of the manufacturer, although he has just fit 2-3 things together. This might be an example where also an end user might become the role of the manufacturer. And this is seen in the second point here, range equipment to a complete machine. That is, for example, very similar to the first topic. Think about that an end user is buying several sub-assemblies from different manufacturers and will complete this machine or this several sub-assembly to a complete production line. So he has a packaging line, he has a packaging machinery, he has and he has an unlock machinery or whatever, and the final product itself is a complete production line. So for a special reason, also the end user become the role of the complete machine manufacturer. Paragraph is also dealing with existing equipment. For example, old machinery might be placed to the market or put into service in the 80s. So it can be addressed to old machines, but for some reasons you may update or upgrade this kind of machinery. In this special case, we are talking about so-called substantial modifications. That means you will modify, or the end user will modify this machine in a very where he has to take into account that this modification has to be seen as an essential modification. Might be the point where you have to change the general or the original safety concept, for example, or result in longer stopping distances for safety devices or other things. On land, the end user has to decide under which conditions he has to have taken into account as essential modification or maybe not. But there's a special document available that is also comes from country to country with Europe. So in the final end, it's not clear and not clear within complete Europe. So it's a little bit depending on the country where we're talking about. Okay. What in principle you need to take into account when you will place a machine into the European market. The thing you need to do is, of course, to ensure that your machine is designed in accordance to the so-called essential health and safety which are defined in the Annex 1 of the Machinery Directive. We checked by, of course, the risk assessment you will do, as we have seen it before. In Annex 1, the essential health and safety requirements, just saying the machine must be safe enough, let's say in easy words. So you will find a lot of in the annex, but nevertheless, in the final sentence is you have designed safe enough or not. So that is in principle the risk assessment. Of course, the second step that is defined to ensure that the technical documentation is available. This is of course to the complete technical file. So there's no need to hand out the complete technical file to your customer, but the technical file needs to be that is available. For example, if an authority with this kind of documents, you have to provide them with the technical file. To provide an instruction manual, as we see it on this point here, is the user information as we see it before. We've seen it before, which is containing all important information which is necessary for a safe use of the machine and the equipment itself. So it covers aspects for the operation, but also for service and maintenance procedures, cleaning procedures, and lots of other things. Then you deal with the so-called conformity assessment procedure. This is a special procedure for Schedule or Annex 4 machinery. So it means there's a special procedure for various machinery like power presses and such things, which has to involve a third party, for example, the TÜV or Notif, for example. But for 90% of the application machinery, that is not needed. After you have done all the several steps, you can create or issue the so-called declaration of conformity and supply it with the machine, and then you can fit or the CE sign, the CE mark on the machine itself. Very few with the general procedure ensure compliance with the machinery directive. The aspects of the machinery directive itself, which is in principle can be seen as a European law. We have on the other side the role of the safety standard itself. The role of the safety standard is in principle to place the general requirements of the directive, but it's not meant to use the safety standard, as we see here some examples. In other words, you have the flexibility to say, okay, I have my own technical solution, which is maybe much than as it is described in the harmonized standard, or you will rely on the so-called presumption of conformity, which means that you have a better comfortable situation in case of liability, for example. So if you can do that, you will comply with the so-called harmonized standard. It's in a little bit more comfortable situation with the visual aspect. So flexibility you have the choice to say, okay, my technical solution might be better than as is described in the standard, or you will feel more comfortable with the solution as it is described in the safety standard. See some examples. In the final end, we have to deal, for example, with 700-800, I'm not sure in detail, 700-800 European standards are just for the machinery directive. But honestly, to say, in many cases, we just need maybe 8 or 10 for a machine. Yeah, so that's my idea. So it's just a few numbers of standards you will really need for your special machine. So one of the standards we have already covered is the Type A standard, EN ISO 12100, as you see it on the top, which is the risk assessment. We have lots of so-called Type B standards, which are covering sub-parts or sub-objects of for example, covering safety distances, emergency stop devices, electrical equipment of a machine, protective devices for light curtains, and so such many other things. And one that we would like to talk a bit more in detail is the standard ISO 13849, which is dealing with the aspects of functional safety. And then we will see a lot of C standards, as you see it here on the bottom line. C standards are such standards which are related to special machines, like wood processing machines, power presses, packaging machines, robots, and other things. So structure the standards in Europe. Question came up from you, and which may ask where I can see if this is a standard, if a standard is harmonized or not. It's a relatively easy answer because we have in Europe a so-called official journal where all standards are published. Yes, and so far standard is published in this official journal. Just need Google type it in new.org, for example. That is one source, but you can find lots of others as well. And then on one side you will end up with the official web of the European Community, and behind the official journal, and there you will find all entries and which has been seen as harmonized. And so far, use the high standard that brings you a more comfortable legal situation in case of a product liability, for example. Said before, we would like to talk about a little bit more in detail about the aspects of functional safety. What does it mean in detail? Functional safety is in principle part of the risk reduction process, and this is relevant for those risk reduction. The reliability is depending on control elements. So now, whenever you will have a risk reduction where control components will be part of the risk reduction process, to talk about the topic functional safety. A control element might be, for example, a classical PLC, a programmable logic controller, as an automation system, but it might also an electromechanical things like a relay, for example. Hydraulic and pneumatic valves, for example, is also part of the safety loop. Often emergency stop device is part of this functional safety aspect. So all things which is to the control circuits, if it's hardware or if it's programmable software, all those things have been covered and be seen on this functional safety. With me here is an example from a so-called web-fed print press, which is newspapers, for example. You can see here you have a drawing point when we have rotating here, so possible to be drawn in and counter-rotating cylinders. Of course, it might be a very dangerous situation for the operator. These cylinders are moving in a very high speed, rotational speed. This web-fed printing press special procedure is, for example, to feed in the paper through the number of cylinders as we see it here. And one of the protective measures the designer has been here is this of safety flap or yes, a safety cup, which is provided, for example, with an interlock switch, with a safety switch here. Would be our example for the next following slides. And the first thing you have to do is, of course, for this safety function, we have to define to set up the necessary risk level. So the first thing you need to do is to define really what is the safety function I'm talking about. I've tried to formulate this in a sentence like the opening of the guard during the operation causes the cylinders to be braked to a halt. So that's the definition of the safety function, and you would agree that on a printing machine we have much just this single safety function, but to be complicated, we would like to start with this easy safety function here. So let's think that's the reference point or process here. Safety function, as we have defined it before, we have to start the so-called determination of the required performance level. The performance itself, as we see it from the risk graph here, is, let's say, numerical assessment, which is relating in 5 levels, A, B, C, D, and E. The performance level E seems to be the risk reduction, and the performance level A seems to be to have the risk reduction. For this safety function, as we have defined it before, we have to select now the 3 risk parameters. The first parameter we have to discuss is the severity of injury. That's the parameter S, and there we have 2 choices between S1 and S2. And we have to ask what is the here I have to take into account. Of course, I think you would. I have to take serious, or maybe also injury, death as a fatal here. For this special reason, we will take into account, select the parameter S2. Parameter which is called the frequency and exposure to the hazard, the parameter F, is also divided into two levels, F1 and F2, where the parameter F1 is shall be selected when you have seldom or too less often, and as a choice for frequent or permanent stay status area. That's less an automatic process. The printing process itself is an automatic process. So we can say, okay, typically it's a seldom except the hazardous area is needed due to the process reason. And therefore we can, for example, argue here for the parameter F1. Called possibility of avoiding a hazard or limiting a harm. That is relating to the speed of the movement, for example, but it can also be the complexity of the system. But for application, I would say, okay, due to the high speed we have in the rotating cylinders, the operator has no choice to avoid a hazard. So if the cylinders will have an unexpected start, for example, that is nearly scarcely impossible or scarcely possible that can avoid this hazard. We have selected for the high speed of the movement of the rotating cylinders the parameter P2 here. Fix the three parameters S2 and P2, and this will relate guides us to the required performance level for a safety function. To solve this problem, so the question now is how we can achieve or how we can guarantee that the performance level D is achieved. Okay, for the moment we have no idea, no clue how that might be come true. So we have a technical solution that might be look in this way here. We have a safety containing two interlock switches on the input level. We have a safety relay. We have selected a safety relay, a logic solver, and we have also actuator part, which is called a contactron. It's a conductor contactor, let's say, which is realizing the safety-related switch-off part to the drives. Selected or separated these components and elements to so-called three subsystems: input, logic, and output. On the next slide, you see the reason why we have done that, because we have different techniques here. As the subsystem 2 and the subsystem 3, that is are so-called safety components. The intended use to ensure safety function. Yeah, so it means this product is already designed and developed with the view of an intended use to be integrated in a safety design concept. So therefore, the manufacturer of these components has already designed designers in which ensure that these components will achieve the highest performance level. In this case, it's performance level E for both components. This declaration and this confirmation we'll find, for example, in our data sheets, which are delivered or can be obtained from our internet shop. Or we are delivering product libraries for a tool which is called Systema, which we'll discuss later during the session. Subsystem number 1 for the interlock switches, for the safety switches as we see it here, we do not get this information directly from the manufacturer, so it's up to us as the designer of a machine to declare if we can achieve the performance level here or not. First parameter which has an influence on impact to the performance level in accordance to ISO 13849 is the category. The category is into 5 levels: B, 1, 2, 3, and 4. And to give you a understanding what is in principle the category, you may have a look to the slide number 18 now, where we see, okay, it seems to be the aspects of the architecture of the structure of the circuit. So that means the difference if I have just a single component like an interlock switch on the first application here. So you ask yourself what will happen in case of a failure. So it means an also be let's say in that way, which has a positive opening actuation. See it here, then as we will open the safety door, this fully will stop the movement because the interlock switch is actuated, but never can not exclude a failure, such failures like wear out parts here on the actuator or broken actuators. It's something we need to take into account, for example. And for this reason, for applications with high risk, we need to, for example, have at least two interlock switches, as we see it here on the bottom line. Yeah, so that means that have a high key that in case of failure, the dangerous movement will be switched off when I open the safety door. And that is the part of the category. So the category is defining the, let's say, the architecture of the subsystem. Slides for an example for what is the principle, the category B or a category 1 architecture is, as you see it here, as category B and 1 is a single channel architecture. That means the failure in one of these components will lead to loss of safety function. That means it's an accept situation, but the first failure may lead to loss of function. It's accepted for category B and 1. The difference between B and 1 is just the component variability, as we see it later. Two, in principle, also a single channel system containing input, logic, and output. But in addition to that, you have so-called test equipment. As you see it here with the letters TE. TE is representing the test equipment, and the OT is the independent switch of path or second switch of output of the test equipment. So in case of failure, when the test equipment will, for example, create a test stimulus on this main, and the test equipment detects failure, then the test equipment will switch off independently the main channel in addition to the first channel. But 2 is typically in architecture for electronic technology. It's easy to realize circuits in a category 2. So main interest to electronic techniques. For category 2, we have also the category 3 and 4. Both categories, category 3 and 4, have a requirement which is defined as the single failure will lead to loss of safety functions. In many cases, we have here a redundant structure to be provided. That means in the case of a single failure that is in the system, shall not lead to loss of safety functions. So that's the reason here dual system. The only difference between category 3 and category 4 is the quality of diagnostics in between those channels that is seen or can be interpreted as this see it here. The difference between 3 and 4 is the quality of the diagnostics. We'll point later. Firm now. As you see here, come back to our example. We have provided 2 interlock switches, and probably both switches will be suitable to be seen this in a category 3 or category 4 classification, because we have a system here. The second data is the data MTF, or the component quality. So to give so the reliability of a component is an important factor besides the structure itself. So in other words, it makes a difference if you have a low-cost component or which just have very low reliability, or you have, for example, good factors, good engineering practice, or good designed product, which also guarantees in many cases a higher reliability of the product. And this is by the so-called mean time to failure, MTTF-D. It's an expected time where this component will not fail. So it's a parameter given in years, and this is typically part of the data sheet of the manufacturer's declaration. So we will get information from the manufacturer of this component, from the interlock switch, that the MTTF of the switch is high. So that we have a third parameter to be evaluated, and this is called the quality or the diagnostic quality. That is for starting with category 2, 3, 4 structures or structures. So to give an understanding what is, for example, meant by diagnostic coverage, think about we have a redundant sensor element, 2 switches, and switches will fail. How good and how reliable we will be able to check if one of these components will be failed, for example. That will, for example, be done by a safety relay, a safety module, as we see it here. The aim of a safety module, the safety relay, is to detect disks in both channels, B1 and B2, as we see it here, for example. B1 and B2. B1 is the first interlock switch, B2 the other one. So if one of these switches will fail, we'll detect this by just comparing both channels together. So it will have a so-called plausibility check as an integral part of the design. So, this is meant by the so-called diagnostic coverage, the quality of diagnostic or monitoring of a failure. You'll find a table inside the standard, which different measures are defined. And for all case here, we will select for a plausibility check, which is given us a high diagnostic coverage. And percentage is 99%, but in words, it's this high diagnostic coverage. So now we have the 3 relevant parameters. We have selected for category 3 or 4. We do not need it know it in detail. You will see it on the next slide. We have selected for an MTTF high, and we have also select high diagnostic coverage. So on the next slide, what performance level we will be able to achieve with that. That is a bar graph or illustration directly obtained from the standard, where you now mix up the 3 parameters: category, diagnostic coverage, and MTTF. So we have an MTTF of high, which is the dark gray color as you see it here. So that means this box. And third parameter where we say, okay, it's a diagnostic coverage of high. Yeah, so it's this here. In combination with redundant structure, this is a category 4. So it means for system number 1, more or less good of performance level E. That is something as we can obtain from the illustration here. Yeah. So nevertheless, also we can calculate this in a very mathematical way, where the tool, for example, will support you, but just having this bar graph illustration, you can have short understand be achieved by which combination of the parameters. Okay, we have covered these relevant aspects, relevant parameters: category, MTTF, and DC. This relevant, which has an indirect influence to the final result. This is called CCF, or common cause failures. The background for that is that in some applications where we have redundant architectures, for example, 2 equivalent switches, safety switches. There might be a common event where, so think about a shock or vibration, for example, mechanical damaging, which will lead to destroy both switches at the same time. And therefore, one measure, for example, to minimize this common cause failure is to use diverse components, as we see it here on this part here. So that means by using diverse components, for example, we can minimize failures by mechanical destroying of these switches. Another example is, for example, overcurrent, over voltage, which is a part of CCF as well. So there are different measures which can be selected and can be seen under this parameter here. Okay, so we selected the most important parameters. We have seen on the bar graph that we will be able to achieve performance level E for the subsystem number 1. For system 2 and 3, get the information from the manufacturer's declaration from the data sheet, for example. And in principle, up to us to say the final validation shows, of course, the required performance level was D for coming out from the risk assessment. We will be able to achieve performance level E. Proceed, we have seen it before. And yes, that's it in principle, the approach. In daily business, it's not in any case that easy as that shown you. That's the reason why, for example, BG has developed a tool called Systema, which is free of charge, and this tool is can be downloaded by everybody. You just need to register you on the website of the IFA of the Germany. The good thing, or the next good thing, is that more or less every component supplier is supporting this tool with a product library. So as you see it here, that's the furniture contact library, and will be updated continuously. So that means you will find all components values of the data sheet also part of the library here. So that makes it more easy, life more easier when using this tool to selecting the right safety functions, the requirements level, and all the details we have discussed before. Yeah, was in principle the let's say the part for the standards and regulations. I would like to take the chance also to present our latest child of our product portfolio, which we have presented just 3 weeks ago at the fair. So it's the safety relay, and I would like to have some words about that maybe. So, just to have in mind what is in principle the same portfolio of Phoenix Contact, which we are offering. Of course, we had since more than 10 years have so-called classical safety relays in our portfolio. We have so-called functional safety relays in our portfolio. We have configurable safety modules in the portfolio, which is dealing with software aspects. So that means configure the software functionality by a tool called SafeConf. And at the final end, we have also network safety solutions. And on the left side, you see that we have, besides the classical safety relay, we have integrated a new class of safety relays, which we have defined as highly compact safety relays in a width of 6 and 12 meters. So that in principle, the portfolio or the main features as we have for the PSR Mini, that's the name of this product family. We are ensuring a high compatibility with all important sensor signals coming from mechanical sensors, magnetic sensors, safety PLCs, safety interlock switches, electronic switches, light curtains, and lots of other things. We have range of approval, starting with performance level 13849, still ATIX approval be installed in Zone 2, for example. Of course, we have, as you note from Phoenix, different connection methods, screw and push in technology here. And the most interesting thing will bring us to design such small and narrow safety relays is the elementary relay itself. So the elementary relay, as we see on the next slide, is in our own development, in our own production here within in Bad Pyrmont, where Phoenix Electronics is headquartered. And it's an elementary relay which guarantees a force-guided principle between the normally closed and the normally open contact. And, the other side, although it's a very small elementary relay, it's same switching capacity as a classical relay. So it's be able to switch up to 6 amp and can be installed in the explosive areas. So there's no limitation in comparison to existing classical relays. We are very proud, for example. So that's the unique thing we have achieved here. But nevertheless, of course, important is what we have done out of that. We have set a portfolio of safety relays for 2 industry. One is the machine building industry, and the second one is the so-called process industry. While in the process industry, more on the area of signal relays. So that means in combination with process controller systems. We are talking machine building industry about applications with emergency stop, with sensors like light curtains, magnetic switches, and so on. And some general key figures out of that. We have a product family called series, which have a 6.8 millimeter wide. We have the MC series, which has a 12.5 millimeters wide. So that's to 70% panel by using the MS series, for example, compared to a classical safety relay, which is in a 22.5 millimeter range. Series, we will be able to have just 50% space requirements of a classic compared to a classical relay. In other words, wherever we have requirements, low space requirements, and high scalability, the P is a very suitable solution. Also, we are guaranteeing very high compatibility to any sensor signal, of course, with all approved in your practical application. Some images how this may look like in the panel and in the cabinet. On the left-hand side, you'll see how that maybe was up to date. We have a panel built up with several safety rates. You see we have a very scalable solution by using, for example, the 6-meter slices. For each safety function, we will be able to have special safety slice. For example, you can connect all the outputs together in a very easy way. And that's also a very smart and scalable safety solution, which is very optimized to save space in the panel and the cabinet itself. My impression here on this panel, you see here, it's very hard to see sometimes. You need to know here in this part, there's the safety. So wherever you have you need to space requirements in the panel. The PSR Mini is one important thing, one important and suitable solution for. Yeah, it has given us the up to the highest performance level for both series, the compact class meter, and also for the 6-meter slice. So for applications, we will guarantee that the highest safety level can be kept here. maybe one comment. Maybe you can ask, the question may arise up, how can I achieve perfect with one safety class, as you see it here on this side here. As I said before, typically I need to have a kind of redundancy. Yes, redundancy by using two elementary relays here on one side. And of course, it's allowed to make a fault exclusion in the wiring here. So far, the safety module and the safety contactors, or the contactors itself, are in the same panel, is typically the case. Another application which is very often used is to use this safety relays as a so-called contact expansion, for example, to valve of frequency converters objective to power adaptation and galvanic isolation. That's another application when safety relays will be used with a semiconductor output of a safety PLC. Okay, any kind of support, starting with, of course, the TÜV certificate, which you will find in our eShop, the instruction manual. This is the data sheet and application handbook we have available, and all kind of safety characteristics for the safety parameters, performance level, seal, and lots of other things. And also, just by having a click on the so-called QR code, if you have a smartphone, just able to read the QR code. Then you get a direct link to the documentation URL, and they will find all these documents available. Was it from my so far? I have to say thank you for listening first. Of course, I think we have a couple of minutes for your questions.
At the moment, there are no questions on Tool. Only questions, please ask them. I want to thank you very much for your presentation.
Yeah.
And thank you all for being here. We will see us on another webinar. Good nice day.
A few minutes?
Yes, we will stay a few minutes here and wait for questions.
Yes.
Goodbye.
Bye.